Welcome back, students. Right, so today let us see what are we going to learn for your board examination. We had left with less number of days, isn't it? Right, so what I did is I picked up all the reagents which are there for in your NCERT, and I'll tell you what is the importance of remembering these reagents. When it is given in the exam, let's see how to remember, because organic chemistry compulsory you'll be getting a question and ask you to identify the type of reagent which is required in that particular reaction. Done. Suppose if you in the examination paper, let's see, I'll be writing the reagent, I'll be telling the mode of action also. Suppose in the examination paper, if you have seen, right, if you have seen anhydrous AlCl3, okay, I'm writing anhydrous AlCl3 in the or AlCl3 or FeCl3 if it is there, right, along with alkyl halide. Okay, remember on the top of the arrow, if you have seen anhydrous AlCl3 and alkyl halide, right, that means alkyl halide is nothing but Rx, isn't it? In the exam paper, if you see like this on the arrow, what should you do? What remember, it is nothing but Friedel-Crafts alkylation reaction. The basic thing is it is Friedel-Crafts alkylation reaction. So what happens in Friedel-Crafts alkylation reaction? We very well know this particular Friedel-Crafts alkylation reaction is used to convert an aromatic ring. That means when you have an aromatic ring like benzene here, or if you have an aromatic ring like chlorobenzene, right? Suppose if you have aromatic ring and on the top of the arrow, if you have, or you have alkyl halide here, you have alkyl halide and you have anhydrous AlCl3 here, or Lewis acid like FeCl3 also, anhydrous AlCl3 or FeCl3. Important thing is it's going to convert, means it's simple, going to cleavage of bond here, cleavage of the bond here, right? So this is going to, this R can be alkyl group, so you'll be getting R here, here also R. Okay, alkyl this is done. So here two products you'll get, one as ortho position alkyl group, one more you will get as a para position alkyl group. So the para product is always the major product, isn't it? What is the name of this? This is 1-chloro 4-methyl benzene. 1-chloro-4-methyl benzene is a major product. Done. So that means whenever anhydrous AlCl3 or in the presence of that is anhydrous AlCl3 in the presence of alkyl halide is given, the reaction which you have to do is Friedel-Crafts alkylation, and these two are the products. You'll be getting R. Here R can be methyl group, it can be ethyl group, like that. Done, students? Now suppose in the exam paper, if you have found to see acyl halide and you're also seeing anhydrous AlCl3 with that. Okay, acyl halide means what? RCOCl is acyl group. This is an acyl group, isn't it? Now that if you observe these, nothing but AR, okay, let us write RCOCl in the presence of AlCl3. That the type of reaction is called Friedel-Crafts acylation reaction, isn't it? Friedel-Crafts acylation reaction. Acylation. What happens in Friedel-Crafts acylation reaction? Here there is a conversion or introduction of an acyl group in the benzene ring. Here what do we write? RCOCl in the presence of anhydrous AlCl3. Correct? Right? There is a cleavage of the bond here. What do you get? You are going to introduce acyl group into the benzene ring, COCH3. Done? Yes. Now suppose in the same thing if you have with chlorobenzene, okay, let me move the paper above. Yes, suppose if I have chlorobenzene here and if I have RCOCl, what do you have? You have a Lewis acid, that is anhydrous AlCl3. Where is the cleavage of the bond? Cleavage of the bond is here, isn't it? So which group are you introducing into the chlorobenzene? Listen, you're going to introduce just see here RCO group, where you'll be getting two products. Chlorine is here only, and you're going to link it with COR. One product at the ortho position, one more product you'll be getting at the para position, COR. Always remember para is stable, isn't it? What is this? This is called 2-chloro acetophenone, and this is called 4-chloro, because you start from here, 4-chloro acetophenone, which is a major product. This is a major product. Done? Yes. Suppose in the exam paper, now remember, if you see this is alkylation, if you see RCOCl, acylation, you need to introduce which group here? In acyl you will be introducing COR, in alkyl you will be introducing alkyl group. Done. Suppose in the exam paper, yeah, if you have observed there is a presence of acetic anhydride. So acetic anhydride, okay, acetic anhydride, how do we write acetic anhydride? Acetic anhydride is nothing but CH3CO taken twice. This is acetic anhydride. Then also what are you going to do? You are going to just see here. How is it written? Basically this is CH3CO, you're linking with one more oxygen, CO, CH3, isn't it? This is acetic anhydride, right? So there's a cleavage of the bond here. Suppose if this is present and if you have a benzene ring, right? Same thing, acetic anhydride, you will be cleaving the bond here, and which will get attached? This will get attached to the benzene ring. So what have we introduced? Which group have we introduced? We have introduced acyl group. So that's why this is also, this type of reaction is called Friedel-Crafts acylation reaction only. Friedel-Crafts acylation. Hope students. So 3 things I have told you. With anhydrous AlCl3, with alkyl halide, anhydrous AlCl3 with acyl halide, and acetic anhydride. Done. That's over. Now next important thing, in the exam paper, suppose if you have seen the presence of concentrated sulfuric acid, always remember concentrated sulfuric acid, what type of reagent is it? Concentrated sulfuric acid is a dehydrating agent. Dehydrating agent. What is dehydrating? Let us write dehydrating agent. What is dehydrating agent? D means removal, hydrating means water. It's going to remove water from that particular alcohol. Okay, so what does it do? So whenever you see concentrated sulfuric acid, suppose which dehydration, it helps in the dehydrating agent of alcohols. Remember, so concentrated sulfuric acid means dehydration of alcohol, will be showing that. Here again you have 2 conditions which you have to remember. So you have to be very careful with the temperature. Suppose if I have an alcohol like this, done. If I have a dehydrating agent, concentrated sulfuric acid means dehydrating, that is nothing but removal of water. I have concentrated sulfuric acid, done. Here also I have concentrated sulfuric acid. Now only difference is, here if the temperature is 443 Kelvin, here the temperature is 413 Kelvin. Remember, in the presence of a dehydrating agent, what is removed? Water is removed. So 1 H from here, 1 OH from here is removed. Again 1 H from here, 1 OH from here is removed. So what do you get? At 443 Kelvin you will be getting an alkene. Okay, this bond is going to shift here. Done. At 413 Kelvin, yes, if I take this 2 moles of this, we will be getting an ether. Symmetrical ether we will be getting. 2 moles of this. So concentrated sulfuric acid, what is the product? It's going to take out water. It's going to dehydrate water from alcohols, forming an alkenes and ethers. Done? Remember. Now let us take one more reagent. Suppose in the exam paper, if you are seeing, which one is this? 5th one. Suppose in the exam paper, if you are seeing anhydrous ZnCl2 in the presence of concentrated HCl, what is the type of reagent this one? This reagent, anhydrous ZnCl2 with concentrated HCl, is called which type? It is called Lucas reagent, isn't it? So Lucas reagent, always remember, at room temperature, we'll be testing it with room temperature. At room temperature, what happened? Lucas reagent, basically it's going to convert tertiary alcohols immediately. Tertiary alcohols, if you add Lucas reagent, rapidly they react. So after reacting, what will happen? They'll get converted to HCl alcohols. That means, how does it this happen? The OH group of alcohol is replaced by Cl group. So what will we write? OH minus is replaced by which one? It is replaced by Cl minus. Okay, this is the nucleophile. This is the case with tertiary alcohols. What will happen to secondary alcohols? Secondary alcohols, if I have to take, when I add Lucas reagent, it will take almost 5 minutes for secondary alcohols to react. Done. Then it forms this product. After 5 minutes, it's going to form the alkyl halide. But when it comes to primary alcohols, okay, primary alcohols, they do not react, does not react at room temperature, does not react. Okay, that is what. So whenever you see anhydrous AlCl3 in presence of concentrated sulfuric acid, only thing you have to do this. See, if it is tertiary alcohol given, form the product and say it reacts rapidly. If it is secondary alcohol given, you have to write it reacts in 5 minutes and then gives this product. And primary alcohol, you will just write it does not react only. That's over, students. Right. Now let us come back to one more. Suppose in the exam paper on the top, on the arrow, if you are given red phosphorus in the presence of X. What is X here? X is nothing but a halogen. X2 can be bromine, it can be iodine. Suppose if you find red phosphorus, what is the main rule of red phosphorus? Red phosphorus helps in the reduction of ketones, aldehydes, alcohols, acids. Remember, what is the role of red phosphorus? Role is it helps in reduction of ketones, it helps in reduction of aldehydes, it helps in reduction of alcohols, it helps in reduction of acids. To which one does it convert into? Alcohol. Suppose if I take alcohols are reduced to alkyl halides. That is the first thing. Suppose in the exam paper, okay, red phosphorus XI understood. Whatever alcohol is there, they getting reduced to that. Suppose if I have to have, or means if I have in the exam paper, same red phosphorus is there, but here I have HI with this. Okay, now there's a difference you have to see. Remember, whenever red phosphorus and HI are present, what is the first thing? Alcohols, they're getting converted to hydrocarbons. Remember, suppose if the red phosphorus and HI are present, your ketones, this is a ketone, isn't it? How much I'll add? I'll add, suppose if I have 4 moles of HI. Immediately, this oxygen is replaced and 2 of the hydrogens come and attack here. Means 1 more will come out as water. So R, this is lost and this gets added here. R, CH2R and water. Suppose if the same HI is there in the presence of an ester. This is an ester, isn't it? This is an ketone, this is an ester. Now here I am adding 6 moles of HI. What will happen? These oxygen are replaced, right? So the hydrogen from here, 3 hydrogens are added to this and 3 will come out as water. 3 to 6. So RCH3 is a product. So if it is red phosphorus in the presence of X, means alcohols are reduced to alkyl halide. If the red phosphorus in the presence of HI, means these are the conditions which you have to remember. I am taking the reagent, I am telling you the mode of action which it undergoes. Now let us take one more reagent. Suppose in the exam paper, what is this number? This is 7. Let us see 8. Suppose in the exam paper, if you see thionyl chloride, SOCl2. This is what? Thionyl chloride. Basically, thionyl chloride role is only one. What is that? It's going to replace OH by Cl minus. So OH minus is replaced by Cl minus. And one more thing is, whenever SOCl2 is there, the gaseous products are sulfur dioxide. We be getting gaseous products, and the gaseous products are what? Gaseous products are sulfur dioxide gas. Economically, this is the best method. So if I take that reaction, now I am taking alcohol, I am going to add SOCl2 to this thionyl chloride. What did I say? This OH is replaced by Cl, isn't it? What do we get? RCl. After that, what do we get? We said sulfur dioxide gas will evolve out, and after that, what is the other thing? HCl also. See here, SO2. The sulfur dioxide gas, HCl also will come out. One Cl is replaced by OH and one Cl comes out. This is the reaction. So sulfur dioxide means replacement of OH by Cl minus. The nucleophile gets replaced, isn't it? Yes, students, done. Now, suppose in the exam paper, I have 2 more things. What are they? Just see this. In the exam paper, if you find, let me write it as in the 9th one. In the exam paper, if I see on the arrow presence of chlorine in presence of ultraviolet light. The same thing in the exam paper, 10th one, if I see bromine in the presence of carbon tetrachloride. This is chlorine in the presence of ultraviolet, bromine in the presence of inert solvent, that is carbon tetrachloride. Chlorine, if it is there, it will always convert alkanes to alkyl halides. This is the reaction which is present in first chapter, that is haloalkanes. Suppose if bromine in the presence of inert solvents like carbon tetrachloride, carbon disulfate, like that, if it are there, they're going to convert alkenes to vicinal dibromide. That means, how does this look? Suppose if I have alkene, H2 double bond CH2. Now what am I going to do? I have on the arrow CCl4, bromine CCl4, nothing. This bond breaks up, you will be getting vicinal means CH. See here, one bromine here, one bromine, and CH bromine. Now add the number of hydrogens 1, 2, 3, 4, 2, 3, 4, 2, 3, 4. So this is called vicinal dibromide. Geminal means same carbon, vicinal means two different carbons, right? Fine. So here I said, if I take alkenes, you have a straight chain alkene, right? You're introducing chlorine, UV light. The hydrogen will be replaced by this and you will be getting, see, Cl. Done? Like this. Right. Now these two reagents are over. Suppose in the exam paper, if I have, let me take the 11th one. If I have sodium iodide as a reagent, okay, done. So basically in first chapter you have two types of this one is the reagents. If you have sodium iodide, and let me take the 12th one, if I have silver fluoride, okay, sodium iodide is one and silver fluoride is one, right? Remember, whenever sodium iodide is there in the reagent, means if it is there in the reaction, what type of reaction are we going to do? We are going to or name this reaction as Finkelstein reaction. Finkelstein reaction. Okay, now suppose if AgF is there, the type of reaction which we call it as Swarts reaction. What is this called? Swarts reaction. This is Finkelstein, this is Swarts. What will happen in Finkelstein? Alkyl halides are getting converted to, because here in this present alkyl halide are converted into alkyl iodides. In Swarts, alkyl bromides are converted into alkyl fluorides. Remember, here this is getting converted to alkyl iodide. The last halogen in Swarts, bromide is getting converted to the first halogen. This is Swarts reaction. This is done, students, right? Now let's see one more. Suppose in the exam paper, what is the name earlier one reaction? It is 13. Now let me take 13 and let me take 14 also here. So in the reaction, if you have dilute HNO3, what should you do, or what will happen? If it is concentrated HNO3, what will happen? Done. If it is dilute HNO3, remember, simple, dilute HNO3 converts phenol into two products. What is that? It's going to convert phenol into orthonitrophenol and paranitrophenol. Okay, right? So what is that? If it is dilute HNO3 in the means as a, if it is there in the reaction along with phenol, it's going to convert into orthonitrophenol and paranitrophenol. Done? Yes. Suppose if there is concentrated nitric acid. Concentrated nitric acid, it replaces immediately all the three positions, that it's going to form 2,4,6 trinitrophenol. How does it look like? Means if I have phenol, OH, if I have dilute HNO3 here, it's going to form two products. What is that? One is orthonitrophenol, which is a minor product. One more is paranitrophenol, which is a major product. This is a major, MJ. If I have concentrated nitric acid with phenol, what should I remember? I have to remember, in the presence of concentrated nitric acid, all the three positions, that is your phenol here, 2, 4, 6. All the three are occupied at one place. So remember this, students. Done. I've completed 14 reagents. Now let's come back to one more. In the exam paper, if I have copper, okay, remember 15th this is, if I have copper, if I see copper in the particular reaction, what should I remember? The first important thing is copper, which type of reagent it is? Copper is a reducing agent. Remember, what are the different types of reducing agents we have? We will see one after the other. Copper basically, again I'm telling you, you have to remember it is a reducing agent. Apart from this, I just now told, say SN by HCl, lithium aluminium hydride, sodium borohydride, all these are reducing agent. Again, if copper is there in the reaction, what does it do? Remember, it's going to convert primary alcohols to aldehydes. It's going to reduce secondary alcohols to ketones. It's going to reduce tertiary alcohols to alkenes. Remember this. And students, right? Primary alcohols to aldehydes, secondary alcohols to ketones, tertiary alcohols to alkenes. Hope I am clear. Now we will see one more. Suppose in the exam paper, if I have this one, what should I do? 16th one. In the exam paper, if you have aqueous sodium hydroxide, okay, aqueous sodium hydroxide, or like aqueous KOH or moist silver oxide, like that. Let me show you with aqueous sodium hydroxide. So let's see, students, now what happens when aqueous sodium hydroxide is there in the reaction. So basically here, let us compare with one more. So in some cases, let me write the 17th reaction. In some cases, you may have aqueous sodium hydroxide or aqueous potassium hydroxide or moist silver oxide. Okay, so what is its role? Let's see. Here, when aqueous sodium hydroxide is present, nothing, simple it is. It basically converts your chlorobenzene. Okay, chlorobenzene is this, isn't it? It's going to convert chlorobenzene to phenol. It's going to convert chlorobenzene to phenol. How does it do? Basically, just see here, NaOH is here. Okay, aqueous is a cleavage of the bond. NaCl comes out and OH is replaced. Right? Suppose the same phenol, further if you are introducing sodium hydroxide aqueous to this, what happens? It's going to form an intermediate that is called sodium phenoxide. Plus water is out. Sodium phenoxide and water, this water is out. Done. This sodium phenoxide, again, we can write it in two ways. One, if the sodium phenoxide is treated with carbon dioxide and H+, the same sodium phenoxide is treated with RX. This sodium phenoxide, if you are treating with carbon dioxide in the presence of acidic medium, see here, this carbon dioxide, whatever is it, it's get introduced into this part. There's a cleavage of the bond here. Okay, there is a cleavage of the bond and H goes and attacks here and COH forms it. Just see here, you get phenol COH. What is the name of this compound? This is called salicylic acid. Same RX when you introduce NaXS1 and you get a product that is ROR. Suppose if you have aqueous sodium hydroxide or aqueous KOH or moist silver oxide. Remember, the moist silver oxide converts alkyl halides into ethers. How we will see. Suppose if I take an alkyl halide C2H5Br plus Ag2O plus Br C2H5. I am taking basically 2 moles of this. See here, this Ag 2 moles and this Br comes out as AgBr. What is left? These two along with this and this is linking to form an ether, symmetrical ether, diethyl ether, isn't it? Yes. Now, suppose if you have 1 mole of alkyl halide, what will happen? We will see. This is 2 moles. Let us take 1 mole of this. But what is the role of moist silver oxide? Basically, they do the hydrolysis process. It's nothing. Moist, this one does, what does it process do? It does hydrolysis. Okay, right. Suppose if you have only one alkyl halide and you're going to add that silver oxide. Let's see what will happen. Basically, before this I said it undergoes hydrolysis, isn't it? Silver oxide combines with water and what does it form? It forms silver hydroxide. Now this silver hydroxide is going to react with this alkyl halide. It is like this, Br plus AgOH. What do we get? We get AgBr out, so C2H5OH plus AgBr. So what are we trying to do? We are saying alkyl halides are converted to ethers. One more, alkyl halides are also converted to phenols. Using what? Using moist silver oxide or aqueous sodium hydroxide or aqueous KOH. Done, students. This is one more reagent which you have to remember. Done. So let's come back and see one more reagent. That is the 18th one. Suppose in the 18th reaction, in the paper, if you have 18th reagent, CrO3. What is the CrO3? Basically, it is an oxidizing agent. Oxidizing reagent. What is its role? Oxidizing agent, always, just remember the sequence first. Always remember, alcohols on oxidation are converted to aldehydes. Aldehydes on oxidation are converted to acids. This is the sequence. One more also I have to say. Alkyl nitriles. This is an oxidation process. This is cyanides or alkyl nitriles on hydrolysis. On hydrolysis in the presence of H plus rho H minus. Alcohols are converted to aldehydes, aldehydes to acids. Now, alkyl nitrides are converted to amides first. Amides are then converted to acids. This is the hydrolysis process. Okay, remember this very important thing. Yeah. So what does this do? Whenever you see chromium trioxide, I said alcohols are converted to aldehydes, but one more thing, if primary alcohol is there, what will happen? Primary alcohol gets oxidized to aldehydes. Secondary alcohols, they get oxidized to ketones. Remember this. One more rule, means in the presence of chromium trioxide. Suppose if I have, right, if I have PCC, one more reagent, very important in aldehyde chapter, pyridinium chlorochromate. Pyridinium chlorochromate, same thing, oxidizing agent only. It gets converts aldehydes, converts alcohols to aldehydes. How? Just see here. If I have an aldehyde like this, sorry, if I have an alcohol like this, if PCC is given in the paper, nothing to do, this alcohol is replaced, means this gets oxidized to aldehyde. Same thing you copy. From here till here, you copy the same thing. CH3, CH, double bond, CH, CH, this one is there, isn't it? Here, your CHO. Wherever OH is there, introduce CHO. Done. This is your chromium trioxide and PCC, students. Hope this is clear. 19 reagents are covered. Now let's come back and write one more reagent, that is chloroform. Very famous reaction, isn't it? Right. But here chloroform with carbon disulfide or bromine. Let's see what will happen. So if I take the 28th reaction here and let me draw one line and make 21st one. In the paper, suppose I think I've already told you, chloroform, carbon disulfide, and bromine. Means what are these? These are the solvents with low polarity. Let us write. If I have chloroform, carbon disulfide, it is a low polar solvent. Low means the polarity of the solvent is very low in the presence of Br2. If this is there. If bromine water is there in the reaction, both bromine only, but here the solvent is different. If bromine water is a reagent, see here. If you find this here, phenol gets converted into two products. One is orthobromophenol and one more is parabromophenol. Suppose if bromine water is there, phenol directly gets converted into 2,4,6-tribromophenol. Okay, this is one thing. Sober? Let us see one more difference, means one more reagent. What is its role? If I take 22nd here and if I say take 23rd here. In the exam paper, now this is clear, I think. Chloroform in the presence of bromine and the solvent is carbon disulfide, a low polar solvent. Means the polarity of the solvent is very, very low. Right? Now, in the exam paper, if I see either ARX or RX, aryl halide or alkyl halide. Along with this, if you see sodium in dry ether, right? Now, here if you see ARX and ARX, means there are 2 moles of ARX and you again have sodium in dry ether. See here, if you have ARX plus RX, what is this combination? ARX and ARX. Aryl halide and alkyl halide, one combination. Aryl halide and aryl halide, one more combination. Once again, aryl halide and alkyl halide, first combination is called which one? Wurtz-Fittig reaction. Aryl halide and aryl halide is called Wurtz-Fittig reaction. But what is here? Most important, sodium and dry ether. I also did one video where I've explained the role of sodium and dry ether. So here, what happens? Aryl halide is getting converted into, means how does it look like this? This is like this, isn't it? Na dry ether plus Rx. This comes out as NaX, and you get Ar linked. Here in this case, Ar, aryl halide, sodium plus aryl halide in this way. You take out NaX, you get 2 aryl halide rings. Done? So this is Wurtz-Fittig reaction, this is Fittig reaction. Now one more we will see. Suppose in the exam paper you have RMGX, very important. RMGX is what? It's Grignard's reagent, isn't it? RMGX is Grignard's. Grignard's reagent, basically they help in, they show addition reactions. They add to the given aldehyde or ketones and undergo hydrolysis and further give respective alcohols. Remember, if you see RMGX, first important thing is formaldehyde gets converted to, undergoes addition, this undergoes addition with RMGX, forms primary alcohols. Acetaldehyde, they form secondary alcohols. Ketones form tertiary alcohols. Correct? Formaldehyde gets converted into primary alcohols. Aldehydes get converted into secondary alcohols, and ketones get converted into tertiary alcohols. 24 reagents are done, students. Right. Now let's come back and see one more type of reagent. Right. So 24, no, let us write 25th reagent. In the 25th reagent, suppose if you are finding acetic anhydride. Right. Let us see what is that. If you find acetic anhydride, what is acetic anhydride? This is CH3CO taken twice. CH3CO taken twice. Oh, this is acetic anhydride. Same thing if you find acetic anhydride in the presence of pyridine. Let's see the product. If acetic anhydride is there, this is going to convert the phenolic group, functional group, into, means the phenolic group is replaced by OCOCH3. Done? Yeah. Let's see the reaction. I have COH and OH. Now I told you we are introducing acetic anhydride. How is this? CH3CO taken twice O. How does this look? Basically this looks like the CH3CO O CO CH3. Where is the cleavage? There is a cleavage here. This OH group is replaced by this group. Yes, this is a group. What do we get? We get COH plus OCOCH3. Right? OCOCH3. Done. Now what else is there? There's this H here that comes out with this as acetic acid. So let us take this one, this cleavage here. This is perfect. OCOCH3 in acetic acid. Suppose if pyridine is there, nothing. Here what are we doing? We are going to use this. It protect. What does it do? The role of this is it's protecting amine group by acetylation. Whenever you have to, because aniline does not undergo Friedel-Crafts acylation directly, so we will be protecting aniline from this, from amine group by acetylation. So it protects amine group by acetylation. How does the reaction look? Basically, you're going to take amine, that is nothing but the aromatic amine, that is aniline. Okay, you're going to take aromatic amine, that is aniline. And when you introduce this, I'm going to take aniline, and when you introduce acetic anhydride to that in the presence of pyridine, like this, if it is, you will get this group. But if you have in the presence of pyridine, I said this group is blocked, means it's protected. What do you get? You get an H and C double bond O CH3. Further, when you introduce bromine in the presence of acetic acid, right? Now NHCOCH3. If you have along with acetic acid bromine, this bromine is introduced at the para position. It is para directing, isn't it? So NHCOCH3 and your bromine is here. Further, if you are OH minus means of H plus, there is a cleavage. There is a cleavage of the bond here. What do you get? You get a product that is NH2PR. This is 4-bromo-aniline. 4-bromo-aniline. This is the product, right? Just see here. Bromo group is here. There is a cleavage of the bond. H goes and adds here. CH3COH comes out. With this OH. With this OH, the acetic acid comes out. So this is the reagent, students. So this is the 26th one. Remember this. Done. Let's see one more. Suppose now which one we have seen? We have seen 26th one. Let's see the 27th one. Here I'll write 28th one. Right. Suppose in the exam paper, if you see phosphoric acid, in the exam paper, if you see sulfuric acid in the presence of Hg plus 2. Phosphoric acid also helps in hydration. What does it do? Here, two conditions. If an secondary alcohol is taken and if we have phosphoric acid, 85% of this, then secondary alcohols converted to alkenes. If your tertiary alcohol is present, if the phosphoric acid is here, they're getting converted to, again, here also alkenes only, but the percentage will be less. If I have sulfuric acid in the presence of mercury, this also helps in hydration only. What does it do? This converts alkynes to ketones. I hope you remember this, students. Hydrating agents. Done? Now, let me take one more. In the paper, if you find, let me take this as 29 and let me break this and make this 30. In the exam paper, if you have calcium oxide and soda lime. In the exam paper, if you have sodium amide and instead of soda lime, you have sodamide in concentrated ammonia. See the difference in products. Whenever you have soda lime, the reaction is called a decarboxylation reaction. Decarboxylation reaction. Remember this. If you have sodium amide or sodamide in concentrated ammonia, then this type of reaction is called a dehydrohalogenation reaction. Dehydrohalogenation reduction. Basically, this is decarboxylation reaction and this is dehydrohalogenation reduction. Here what will happen? Sodium salts of carboxylic acid. Sodium salts of carboxylic acids are converted to alkenes. But what is here? Here you will be getting one carbon less alkene. Here, basically NaNH2, what is its role? It deprotonates. Means it deprotonates alkynes, alcohols. Dehydrohalogenation means it will remove hydrogen as well as halogen. By what? How does it do this? By deprotonating what? Alkynes and alcohols. Okay, 30 are over, isn't it? Let's see some more. Now let's see the 31st reagent, students. So 30 are over, right? Now next important reagent which you have to remember. Suppose in the exam paper, if you see any of these reagents like Rani nickel in the presence of hydrogen, or if you say palladium in the presence of hydrogen, platinum in the presence of hydrogen, sodium and alcohol. All these are reducing agents. One more is there, lithium aluminum hydride, tin in the presence of concentrated HCl. What are these? All these are reducing agents. What are they going to do? Let's see. Suppose if I have an cyanide or alkyl nitride, if any of these reagents are there, just see here, it will help. I said these are reducing agents. They're going to add one, this bond is broken, one hydrogen is added here and one more hydrogen, like no one more bond broken, one more hydrogen, you get RCH2NH2. Suppose if you have an amide like this, RCONH2, you have the same reducing agent, lithium aluminum hydride here. See here, this oxygen is removed and you'll be getting RCH2NH2. It's going to get converted to amines. Amides to amines, alkyl nitrile to amines, reducing agents. Done? Suppose in the exam paper, if you see zinc amalgam, here you have seen tin and concentrated HCl. If you see zinc amalgam in the presence of concentrated HCl, first important thing, zinc amalgam in the presence of concentrated HCl, which type of reaction is this? This is called Clemenson's reduction. Clemenson's reduction. Remember, Clemenson's reduction. What does it do? It's going to convert ketones to alkanes. What does it do? It's going to convert ketones to alkanes. This is also a reducing agent. This also is a reducing agent. But here, alkyl nitriles to amines, amides to amines. Here ketones are getting converted to alkenes. Done, students? Right. There is one more. Now we are talking about reducing agents, isn't it? Now let's see oxidizing agents. 33 one, let us take. Now what are the oxidizing agents? This is alkaline KMnO4 is an oxidizing agent. Chromium trioxide is an oxidizing agent. So chromium trioxide in the presence of acetic acid, this is an oxidizing agent. These two are reducing agents. These are oxidizing agents. What do they do? These oxidizing agents are going to convert aromatic alkanes, whichever aromatic alkanes you take, they're going to convert it to acids. How does it look like? Now I have an aromatic alkane, that is toluene. So when I introduce KMnO4 to this, aromatic alkane gets converted to which one? Acid. Which is COH, acid. And students, aromatic alkanes to acids. These two are reducing agent. This is an oxidizing agent. Now, next thing, let us see one more. 33. Suppose in the reaction, right? If I have, now reducing agents are over, oxidizing agents are over. In the reaction, if I have alcoholic KOH in the presence of sodium ethoxide, and if you have aqueous KOH, now let me make this as 34, aqueous KOH. Here, aqueous KOH, what is this? This is alkaline in nature, isn't it? Alkaline in nature. Now, if you have alcoholic KOH, aqueous KOH, remember, in the presence of alcoholic KOH, this prefers more of elimination rather than substitution. This converts alkyl halides to alkenes plus KBr plus water. It also helps in synthesis of ethers also. Okay, that's also alright. Helps in synthesis of ethers. But when it is aqueous KOH, I told this is alkaline in nature, it's going to convert, see here, if I have aqueous KOH like this, KCl comes out and this is going to form ROH. Done? Yes, that's true. Now let's see one more. Many important reagents which you have to remember. So I've listed out if they're similar like this. Let us see one more reagent, that is the 35th one. In the exam paper, if I have AgNO3, so AgNO2, this is very light. In one of the CBSE sample paper also they have given AgNO2. Let's see that. If you have AgNO2 1 and if you have 36th one KNO2 one more, potassium nitrate and silver nitrate, AgNO2 converts alkyl halides to RNO2 plus AgX. Potassium nitrite converts alkyl halides to RONO, ambidentate ligand, plus KX. This is the difference. AgNO2 to alkyl nitrite, this gets converted to RONO. That's the difference. Yes, students? Now, let's see one more. 37th one. This is very important. Suppose in the a question paper, if you have a reagent which has, means if you see like this, NaOH and Br2, what is this reagent? This reagent is called Hoffman reagent. What is it called? Hoffman reagent. What is its role? Its role is to convert amides to amines. And this amines, if you're heating with chloroform and potassium hydroxide, what does it do? Amines get converted to isocyanides. Remember this. Sodium hydroxide in the presence of Br2, what does it do? It's going to convert amides to amines. Amines in the presence of, or chloroform KOH. One more thing is here. This amines, if you heat, you get, or if you take one more amine, means if I take the aromatic amine, let's see that. Let me make one link here. Here what happens? If I take aromatic amine, ArCONH2, okay. This aromatic amine, if it is treated with, let me write this chloroform here, CHCl3 plus KOH. Then this gets converted to ArCH2 and C. This is the thing. Okay, means amines getting converted into aromatic amines. Then further treatment with CHCl3, it gets converted to isocyanates. This is Hoffman reagent. One more reagent which I would wish to say, that is ArSO2Cl. What is the name of this reagent? The name of this reagent is Hinsberg reagent. What is this? This is Hoffman reagent. This is Hinsberg reagent. What does it do? Hinsberg reagent basically converts. Yeah, just see. What is Hinsberg reagent? Let us write this formula. What does it convert? Let's see. This is your Hinsberg reagent. SO2Cl plus this is your primary amine. The same Hinsberg reagent, if you take and you are introducing secondary amine, okay, secondary amine means here you have 2 H in secondary amine, only 1 H. What do you get? HCl is out. Here also HCl out. Let me write one product. This converts into SO2 NH C2H4. What is the name of this compound? This is called N-ethyl benzene sulfonamide. N-ethyl benzene sulfonamide. If this is there, in this case, product ring double bond O NR C2H. What is the name of this? NN diethyl. NN diethyl benzene sulfonamide. Diethyl, no, 2 alkyl groups are there. NN diethyl benzene sulfonamide is one more. So this is what you get with Hinsberg reagent. We are almost coming closer. Aldehydes chapter, we are coming off to 39th reagent. Suppose if you have seen DIBAL. DIBAL. What is DIBAL? DIBAL is nothing but isobutyl aluminium hydride, isn't it? DIBAL is this presence of water. What does DIBAL do? When in the paper they'll give you DIBAL only directly. DIBAL converts cyanides, or it acts as reducing agent. Cyanides are reduced to aldehydes. Esters are also reduced to aldehydes. Remember this. That is a work of DIBAL. Yes, students? Yes. Now, next important reagent, that is Tollens reagent and Fehling solution, isn't it? What does Tollens reagent do? What does Fehling solution do? What does it convert? Let's see. Now, what is Tollens reagent? Basically, Tollens reagent is nothing but ammonical silver nitrate. Correct? Right. Ammonical silver nitrate. So, what does it do? If you see ammonical silver nitrate, what do you see? It is Tollens reagent. Tollens reagent is an oxidizing agent. It converts aldehydes, means aldehydes in oxidation. What does it do? They get oxidized to whatever aldehyde you take, the corresponding acid. Aldehydes gets oxidized to acids corresponding, means acids, no? It gets, or corresponding carboxylate anion. This is Tollens reagent. Suppose if I have one more, 41. I told you, isn't it? Zinc amalgam. I told already. This also you know, students. If you see zinc amalgam in the presence of concentrated HCl, what is the type of this? This is called Clemenson's reduction. Clemenson's reduction. Here in Clemmenson reductions, now aldehydes are oxidized to acids. But this is oxidation. The same thing if reduced. Ketones are reduced to alkanes. Remember, alkanes. So if you see this reagent, simple ketones, whichever ketone is given, do the reduction process and it's get converted to alkanes. These are the important reactions of aldehydes. Now let's come back to the last chapter, that is amines. Basically, NaNO2 plus HCl. NaNO2 plus HCl, what is it? This one? Whenever you see this, what reaction? This is called a diazotization reaction. Diazotization reaction. Here diazotization, nothing. Basically, your aniline is getting converted to BDC, that is benzene diazonium chloride. That means if your aniline is there like this, NH2, and if you are introducing NaNO2 plus HCl, what do we get? We get BDC, N2Cl. This is your BDC, N2Cl. Suppose if you have, this is aromatic amine. If you have aliphatic amine, if you are introducing NaNO2 plus HCl, what do you get? You're going to get alcohols. That's it. One more thing we'll see. One more reagent important. If you have CuCl by HCl, or if you have seen CuBr by HBr, if you have seen CuCN by KCN, what are these? This basically are the reagents used in Sand-Meyer's reaction. Sand-Meyer's reaction. What does it do? Sand-Meyer's reaction, here aniline is getting converted to BDC. In Sand-Meyer's, the same BDC we take into Cl. If you are introducing CuCl by HCl, it gets converted to Cl plus N2. If you take same CuBr by HBr, here instead of chlorine you will be getting bromine. Bromine plus N2. Same thing if you introduce CuCN by KCN. CuCN by KCN, you get cyano plus N2. Hope this is clear, students. This is called Sand-Meyer's reaction. Now let us see the 44th one. If you see only copper by HCl or copper by HBr, what is the type of reaction? This is called Gattermann reaction. Gattermann reaction. what will happen? Nothing. Your BDC, whatever benzene diazonium chloride is there, that's get converted. Means if you have copper in the presence of HCl, this is replaced, nitrogen gas comes out and you get Cl plus CuX. The same thing, BDC is introduced, or it is, you have copper in the presence of HBr. Instead of bromine, this will, instead of chlorine, this becomes bromine. You get N2X plus CuX. Right? So these are the reagent, students. So I've collected maximum of them, how much ever I could. Everything is covered. Try to solve it. Please go through all the reagents, practice them. If anything is left out, I'll be putting or uploading it daily basis. All the best, students. I'll meet you again with next important topic, that is paragraph based questions. All the best.